What's up, guys? Welcome back. Patrick here. Moving on to the next question. Got the limit as x approaches positive infinity of ln x minus x. This is a pretty popular question. I see it come up in textbooks a lot. A lot of profs sometimes cover it in class. Sometimes you'll see this reverse. You'll have x minus ln x instead of ln x minus x, but the process is going to be exactly the same. Now, first thing you want to notice is if you do a direct substitution, if you plug in positive infinity, what's going to happen here is this ln x is going to go towards positive infinity, and then this x is going to go towards positive infinity as well. So notice that you end up with an indeterminate difference. Okay, so we have to come up with some kind of other strategy. Now, what we've been doing so far is sometimes getting a common denominator, taking two expressions, converting them into one. But notice this one is going to be tough to do that process with, because ln x, we can't really convert that to anything, and then the x we can't really convert to anything. Notice we can't rationalize this. There's no square root here. And so I mentioned this in a previous video when we first started talking about indeterminate differences. Another strategy is factoring out something. And what you actually do here to solve this kind of limit is you want to factor out an x. And so if we factor out an x, what's going to happen is everything's going to get divided by x. So this ln x is going to get divided by x, and then the x is going to get divided by x, which is just going to be 1, like that. So notice if we took this x that we factored out and we went back the other way, if we distribute into this bracket, these x's would cancel out. You'd end up with a ln x. Then x times -1 would just be negative x. So what you want to do here now is notice you got two expressions that are multiplying by each other. So what we can do using properties of limits is we can split these limits up. We could have the limit as x approaches infinity of x, and then we could have another limit as x approaches infinity of ln x over x minus 1, like that. And then from here, we know this is going to go towards positive infinity. But this limit here, it's not as obvious. So what we can do is the properties of limits again. So we can take the limit as x approaches infinity of ln x over x minus the limit as x approaches infinity of 1. Right? So I applied the properties of limits twice to the overall function here, and then to this function. It was two functions that were subtracting, so we could split it up into two limits. So what I'm going to do is I'm actually going to deal with this limit first separately on the side here. So we got ln x over x. Notice if we do a direct substitution on this, it's going to be positive infinity over positive infinity. And because it's in this format, it's an indeterminate quotient, what we can do is apply LHospitals Rule on this. So we'd have the limit as x approaches infinity of ln x would be 1 over x. The derivative of x is just 1. And so we would end up with the limit as x approaches infinity of 1 over x, right? 1 over x divided by 1 is just 1 over x. And then 1 over infinity, we know that that's going to go towards 0. So this limit here equals 0. And so if we sub in that result, this is going to be 0. And then the limit as x approaches anything of a constant, it's just equal to that constant. And so what ends up happening is we end up getting positive infinity times -1. 0 minus 1 is -1, which ends up being negative infinity. And so that's the final answer for this limit over here, right? So a bit of a unique strategy that we haven't covered yet. We actually had to factor something out. We factored out an x, and then we ended up with these two expressions that were multiplying, properties of limits again, and then we had to deal with this ln x over x, this limit here, using LHospitals Rule. Now, sometimes you'll see this limit given as x minus ln x. That's another popular format. process is exactly the same. The only thing that's going to change is this is going to be interchange, and you'd end up with, what would you end up with? You'd end up with 1 minus 0. So this would be a positive 1, and you'd get positive infinity. So only this bracket would be interchange, but you would still be factoring out an x using the properties of limits, exact same process. This would be positive infinity, right? But if you got ln x minus x, it equals negative infinity, and that is the process.